8.4 day 4, we're going to continue graphing in standard form. So just like yesterday, we're going to find the vertex first. To find the vertex, we're going to identify A, B, and C. You don't have to write it on your paper unless it's useful for you to write it. Since it's y equals negative 2x squared, A is negative 2, B is positive 8, C is negative 1. And then to find the vertex, I'm going to do H equals negative B over 2 times A. Okay, let's simplify that. So negative 8 divided by negative 4 is positive 2. So the vertex is going to be 2 comma something. To get the y coordinate, I'm going to plug my x value, which is 2, back into the original function. I'll give you the y value. You can write y equals, or you can write k equals. K equals negative 2x squared plus 8x minus 1. And where the x is, I plug in 2. And then just remember to respect your order of operations. So exponent first. 2 times 2 is 4 plus 16 minus 1. Negative 8 plus 16 minus 1 is 7. So my vertex is at 2 comma 7. I'm going to go ahead and graph 2, 7 while I remember. So from the origin, write 2 up 1, 2, 3, 4, 5, 6, 7. Okay, because it asked for the axis of symmetry, I'm going to include it. If it didn't ask, I would probably still include it because it's a useful point or line. The axis of symmetry runs through the vertex, the vertical line, so it has to start with x equals. If I do a vertical line through the vertex, it's going to hit at x equals 2. Or if I look at the vertex, the x value at the vertex is 2. So x equals 2 is the axis of symmetry, and I'll go ahead and graph it because it's useful. It helps me keep track of which point is the vertex. Okay, the y-intercept. The y-intercept is the c value. A y-intercept is always going to be 0 comma something. So if I go back to the original function, the c value is negative 1, so that's going to be the y-intercept. So 0 comma negative 1 is the y-intercept. On the y-axis, 0 down 1. Okay, I'm going to go ahead and graph the symmetric point to the y-intercept. The graph is symmetric across this axis of symmetry. So from the symmetry line, the y-intercept is 2 to the left. So from the symmetric line, there's a symmetric point 2 to the right. Okay, 3 points is enough to get a good graph. So I'm going to leave it like this, but I'm also going to look at it to see how we could check to make sure our graph's correct. Okay, this is a good graph. It includes 3 points. It looks nice. If I go back to the original function, since there's a negative in front of the x squared, it should be opening down, which it is. There's also a vertical stretch of 2. So from the vertex, it should go right 1, down 2. And if I included those dots, it would match up there. So I think I did it correctly. Okay, let's try the next one. Okay, I'm going to identify A, B, and C, but again, you don't have to, as long as you can plug them in correctly. Since it's negative x squared, A is negative 1, B is negative 6 for negative 6x, and C is negative 4. To find the vertex, H equals negative B over 2A. Negative B. B is negative 6. So if I do negative 6, it's going to turn it to positive 6. So if you change it straight to positive 6, that's fine with me. At the bottom is 2 times A. A is negative 1, so negative 2. 6 divided by negative 2 is negative 3. So the vertex is negative 3 comma something. Okay, to get the y coordinate of the vertex, I'm going to plug my negative 3 back in the original function. You can write y equals or k equals, because we often use k for the y coordinate. Now you're going to be really careful when you plug in, because you're plugging negative 3 in only for the x spot, not for the negative. So it's negative, and it should be x squared minus 6x minus 4. And the parentheses should only go on the x part. For the x value, I'm plugging in -3. So negative x squared minus 6x. Okay, and then you're going to be really careful with your signs. I'm still doing the exponent first. The exponent is only applying to the parentheses, so I'm doing this part first. Equals, I'm going to bring down the negative. If I do the exponent, I'm squaring the -3 because it's in parentheses. If I do -3 times -3, I get a +9. -6, -3, positive 18 minus 4. -9 plus 18 is 9 minus 4, which is 5. So my vertex is -3, 5. Now I'm going to go ahead and graph that. 1, 2, 3, 1, 2, 3, 4, 5. I graph it before I forget which one's which. Okay, it says draw the axis of symmetry. The axis of symmetry is a vertical line through the vertex. Okay, axis of symmetry, again, you can get it by looking to see where the line hits the x-axis, it hits a -3, or looking at the x-coordinate. So x equals -3, axis of symmetry. The y-intercept is the c value, or it's the number at the end here. So the y-intercept is 0, -4. I'm going to graph the y-intercept. 0, down 4, 1, 2, 3, 4, and it should be on the y-axis. This is the y-axis. Then I need a symmetric point to make the graph look nicer. This is the axis of symmetry, or the line of symmetry. Since the y-intercept is to the right, there should be a matching point on the left. If you can tell where it's going to go, you can just plot the point. If you can't tell, you can count. So from the y-intercept to the line, it's 1, 2, 3. So on the other side of the line, 1, 2, 3, there should be a symmetric point. Okay, and then 3 points is enough to go to graph, so I'm going to go ahead and sketch it. And then just to check to make sure my answer makes sense, if I go back to the original, since it's a -x², it should be opening down. It looks like it does. Since the coefficient is -1, it should go right one, down one. And it looks like it would have had I graphed more points. Okay, let's do a couple more. Same way though. Okay, so I'm going to identify ABC. You don't have to, as long as you plug them in correctly. So since it's 2x², a is +2, it's +4x, so b is 4. The c is the number at the end. There is no number at the end, so c is 0. There is still a c value, it just, we don't bother writing it when it's 0. Okay, h equals -b over 2a. So -4 divided by 4 is -1. So the vertex is -1, comma, to get the y-coordinate, k equals, or y equals 2x² plus 4x. And then where the x is, I plug in the -1 because I already know that's the x-coordinate of the vertex. And then just make sure we do exponent first. -1 times -1 is positive. 1 times 1 is 1. The vertex is -1, -2. I'm going to graph it before I lose track of it. Draw the axis of symmetry, which I do even if it doesn't ask me to because I find it useful. The axis of symmetry is hitting the x-axis at -1, or it's because the x-coordinate is -1. Okay, the y-intercept is normally the number at the end, but there's no number at the end, which means the y-intercept is at 0, 0. 0, 0 is right here at the origin. The graph still should work though. Okay, since the y-intercept is to the right of the axis of symmetry, there should be a matching point on the left of the axis of symmetry. From here to here is one space. So from here to here, I'm also going to go one space. And as long as I have 3 points, that's enough points for my graph. I'm going to look at my graph and check it. If I go back to the original equation, this is a positive 2x², so it should be opening up, which it is. There's a vertical stretch of 2, so from the vertex, it should go right one up 2, which it does. So I believe my graph is correct. Okay, one more with a fraction. Again, A, B, C. Don't have to list them out if it's not useful to you. So 1/2 x² minus 4x plus 1. h equals negative b. Since b is negative 4, you could change it straight to a positive 4 over 2a. And there's a fraction, but we're not going to freak out about that yet. A negative 4 switches to positive 4. If I do 2 times half, that's the same as saying, what's half of 2? Half of 2 is 1. So 4 comma. Okay, let's get the y value. 1/2, and we're going to plug it in, and then we'll figure out the fraction. 1/2 x squared minus 4x plus 1. Where the x's, I plug in 4 because that's the x coordinate of the vertex. Okay, and in order of operations, I'm going to do the exponent first, do the half later. 4 times 4, 16. Okay, there is a fraction, but it's half. So half of 16 is 8 minus 16 plus 1. 8 minus 16 is negative 8 plus 1, negative 7. So the vertex is at 4, negative 7. From the origin, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Axis of symmetry goes through x equals 4. The y-intercept is the 0, 1. Okay, symmetric point. This is the axis of symmetry. Since the y-intercept's to the left, there should be a matching point to the right. It is 1, 2, 3, 4 spaces to the left, so 1, 2, 3, 4 spaces to the right, and it should look symmetric. Okay, we sketch, and then we just verify that it makes sense. Okay, if I go back to the original, this is a positive half x squared. Since it's positive, x squared is opening in the upwards direction, which looks correct. The a value is 1/2, which means it normally goes right one and it only goes up halfway. That looks reasonable for our graph.